This video introduces you to the diversified crypto protection implemented in the Aspire project. The security requirement of this diversified crypto library is confidentiality because a static cryptographic key is hidden within the library. This data obfuscation is done at compile time. The security storage used to hide a static key can be used as well to hide dynamic key used in the application, but in this case the protection is less strong because the key value will appear in clear in memory when the key will be used by the library. It's a flexible crypto library because some specific function can be added to the existing cryptographic function already available in the library. The issue addressed by this protection is code that exposes a cryptographic key in clear. An attacker can statically retrieve the key value, or dynamically, as shown in this diagram, the attacker can dump the argument passed to the cryptographic library and retrieve the key value. The protection enables to embed the key with the library in such a way that it's very difficult to retrieve it for the attacker. The protection is flexible because in addition to standard cryptographic functions, some extra behavior can be provided in addition within the library. For the purpose of the one-time password OTP use case, a master key is protected thanks to the diversified crypto library, and the key derivation plus the OTP generation themselves are also embedded in the library. Let's see in practice how it works with the code. This is the source code from the OTP use case used in the project. Here we have a macro, and provided diversified crypto library is invoked or not, it will generate either this pragma that I will analyze in a minute, or it will restore the original code with the call to build master key, where all these bytes here are the free beginning bytes of the master key, and the last byte will be will be processed and prepared by the function itself. Then what is in the pragma here? We passed the value of the master key that will be prepared and obfuscated in dedicated binary. Then this binary value will never appear in the code. Let's see then, in case DCL is not invoked, then without the protection we have this C code that will be processed by ACTC. Here we can see the call has been restored, and this is what will be in the generated code. Let's see, there's a generated code I have prepared before with obj dump. This is the call to build master key. Then I'll check after. I'll show you that it's the same line number. This is the call to build master key. Here we have 8 arguments passed. Then the 4 first arguments are passed in the registers, and then the remaining in the stack. Then the attacker has the ability either to retrieve the bytes from the registers and from the stack with debugger, or you can just wait here that the build master key returns, and thanks to this address here in the register, it will directly access the value of the master key. Then this is for the code compiled without the protection. Let's see quickly in the code. Then line number is 2463, and here if I click, we should see the same. Here we have 2463. Then this is the same. Then this is for the code without protection. Here is the code before C generation. That is where the macro is there to differentiate between the code with or without the protection. Then if diversified crypto protection is invoked, then this pragma will be generated. Let's say this in this new Emacs that I've prepared in the meantime. I have to go to the C. Here the pragma is generated in the code, And let's see now, I have in my in the shell I have use objdump. Then with objdump here we can see there is a call to DCL, it's DCL in it, but with this there is no more value, the value of the master key have vanished because it has been obfuscated and put elsewhere. What is done by ACTC is to take, when compiling this C code, is taking this value here, giving this to the protection that obfuscated and put it in a specific binary. The important fact is that the value of the key is no more passed here as argument to the build master key, that the build master key have vanished, by the way. Ideally, the code here would disappear because it's these variables are no more used, but this is more optimization and toggling. This concludes the video on the Diversified Crypto library. The Aspire project has received funding from the European Union 7th Framework Program under Grant Agreement number 609734.